Hey everybody, this is your 2-4 pre-cal video. So your couple of objectives are to be able to graph the functions in the library of functions and graph piecewise. So it's not that difficult as far as graphing. You're just going to have to use your calculator. So while we're studying this, there are many types of functions which are studied in the section. Piecewise defined can be used for absolute value. So with two pieces, y equal x is the positive side and y equal negative x is the negative side. So let's look at that. The absolute value graph looks like this. And so as an absolute value, you would say f1 of x equal, that's when you have to push the button to the right of the 9. So going over to this, the button to the right of the 9, and we want to make it a piece with a condition part as well as an expression part. And so we do the expressions first, and then this would be when it's x less than 0. So you do x control equal less than 0, or you could put less than or equal to. Since I didn't, this time I'm going to put greater than or equal to. And let's see if that's right or if I have it flipped. And I have it flipped. Okay, so this needs to be negative x, that makes sense. And then this is positive x. Okay, so we can copy that down over here. It's the expression negative x when x is less than 0 and x when x is greater than or equal to 0. And that's going to be equivalent to if you just did the button again to the right of the 9, but this time actually just use the absolute value symbol. And so it made it red, then purple, which means it matches. You can also go to your table, and for every value, like these are my x's, but if I compare my f1 and f2 values, they match. So those are two different ways you can do it. Okay, so y equal x is the positive side, y equal negative x is the negative side. Piecewise also can be defined and used when a graph has two or more lines or curves. Sometimes you're going to have to find the equation of them using graph, slope, and y-intercept. So regarding step functions, to help us better understand this, let's consider a real-world example. Suppose a person starts a cleaning business. They decide to charge each client based on how many hours they work for the client. If it's less than 1 hour, it's $10. So that's like your setup. And then from 1 to 2 is 20. From 2 to 3 is 30. 3 to 4 is 40. So that means if you work from 1 to 59 minutes, it's $10. And if it's from 1 hour to 1 hour 59, it's $20 and so on. We see that the amount remains constant on the hour-long interval, but varies on each of those because it goes up an hour. So if we graphed that, we said it was $10 from anything, I'm going to make a hole in this graph, up to 60 minutes. I'm going to say these are minutes and these are dollars. Because to me, minutes would be easier to work with than hours, because you'd have to do 1.5, 2.5, and so forth. So this one's a solid one, and that's going to be $10. The next one at 20 starts from here on, and that'd be for 2 hours, which is 120 minutes, and so on. So you can see it goes bubble, solid, and so forth. Because if it's 45 minutes, then you're there at $10. If you're at 90 minutes, you're there at $20. Okay, so that's your everyday life example of how that would be graphed. The properties of the square root of x, which we just call as a square root of x. Now, by the way, when you're typing this, whether it's in Word or Google Docs or whatever, it means the square root with the top on it, but it doesn't really do that. So sometimes we do like that with parentheses. Anyway, the domain and range are the set of non-negative real numbers. So in other words, x greater than or equal to 0, y greater than or equal to 0, or you could just say 0 to infinity for both. So that's the square root of x. So we're going to delete this. Square root x. Okay, there it is. So it's 0 to the right, and this one is 0 and up. So this one means right, and this one means up. Okay, and then the x-intercept is 0, the y-intercept's also 0. It's neither even nor odd, because it looked like that it's increasing from 0 to infinity. It has a minimum of 0 at 0, and that's the function properties. Now you have the third root of x, which is the cube root. So this time you can do control up arrow. So if we do this, control and then up arrow, that lets you type in whatever root you want. So like you put a 3 there for cube root, etc. So cube root of x looks like that. This time the domain and range are all real numbers. See? And the x-intercept and y-intercept would also be 0 like that other one. It's symmetric to the origin, so it's odd. It's increasing throughout everything, and there's no local maxes or mins. The next one is the absolute value function, so that's the v. The domain is everything. The range is y greater than or equal to 0, which is 0 infinity. The x-intercept is 0. The y-intercept's also 0. So again, these are the parent functions. It's symmetric to the y-axis because it's the same on the left and right, which means it's even. It's decreasing on positive infinity 0. Let's look at that. It's from negative infinity to 0. Okay, so this is a typo if you want to fix this. And then it's increasing on 0 to infinity. So fix this one spot right there. It's got a minimum of 0 at 0. Now the constant function is a real number like that. Doesn't matter if it's 4.5, if it's the square root of 5 or whatever. It's a real number. It's a flat line, neither increasing nor decreasing, and it's even because it's on both sides. So symmetric to the y-axis. The identity function is what they call the linear parent function. That's like y equal x, and it's odd. It's increasing throughout. The square function is even. It's u. It's decreasing from negative infinity to 0, and it's increasing from 0 to infinity. The cube function is odd, and it's increasing throughout. The square root function is neither even nor odd. It's increasing throughout from 0 on, like that. Again, the cube root function is odd because that's the one like that. The reciprocal function is also called the rational function. It's like 1 over x, and it looks like this. Because x is in the denominator and is a ratio or fraction. So this is the one for 1 over x. This is the one for negative 1 over x. This is the one for positive 1 over x squared. So if it's x squared, then both are up. And if it's like that, that's negative 1 over x squared. So both are down. Again, the absolute value function, x, it's even, it's a v, it's decreasing, and then it's increasing. Now, if you didn't want to use that other button, you could type ABS(x), and that works. Then there's the greatest integer function. It's the greatest integer less than or equal to x. It's also called the step or round down. It's neither even nor odd. And you can type int x if you wanted to. And you would need to change your table count to 1/2 to see the ordered pairs for it to work. So that would look like this. And so forth. Piecewise have 2 or more parts over different intervals. Sometimes they're not continuous. And they have holes in the graph. Pay attention to your boundaries and critical points, which are the points of interest. And again, use your button to the right of the 9. Okay, so your types of problems are graphing the functions in the library and graphing and analyzing piecewise. Okay, so let's get started on the problems. On the first one, we just have to graph that. And so we go to the doc. New document, negative square root of negative 9x. So that looks like that, which is D. The next one, 36 over x, it should be based on like 1 over x, which is positive and negative. So probably like those. Or is it like this? Let's graph it and change our window. So if we do 36 divided by x, looks like that. And we change this to be 14. This one also to be 14. This one to be negative 14. I think that's what it has. Yeah. Negative 14. And this one to be negative 14. Okay, so it shows a lot of that, which is the D graph. Okay. The next one says less the intercepts of it of x cubed minus 8. So x to the 3rd power minus 8. Okay, it looks like that. You have one of them at 2, 0. How you can do it is if you say 0 equal x cubed minus 8, 8 equal x cubed, and then do the cube root of 8. Which is 2, since it's like 2 times 2 times 2. Okay, so that's one of them. The other is based on this, which is your y-int. So that's going to be 0, negative 8. So you do have 2 answers. The order doesn't matter, but you do have 2 answers on that one. If it were a 27, you'd have 3. If it was 64, you'd have 4, and so forth. Okay, so that's A. Okay, number 4. X squared is decreasing on the left side. So from negative infinity to 0. But don't use the bracket. You have to do the parentheses. Okay? Use parentheses on increasing and decreasing for the X values. Okay, the next one, when they're defined by more than one equation, they're called piecewise, or piecewise defined. Think of it as parts, part 1, part 2, part 3. Okay, number 6, cube is odd and is increasing. That's true because it looks like that. The cube root function is odd and is decreasing. Don't think so. It's increasing throughout. So it's wrong because of this. That should be increasing for it to be true. Again, like I said before, be careful because sometimes false is on top and sometimes false is on bottom. The next one, the domain and range of the reciprocal function are all real numbers. That's false, which is 1 over x, because it's like this. We have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. So that means your domain would be the set of x's such that x is not 0. The range would be set of y's, so y is not 0. So think of reciprocal and rational. Reciprocal because it's 1 over that, and that's also how we say rational. Okay, and they give you a graph, and this one, of course, looks linear. This one looks like an absolute value because it's a V. This one is a U graph, and so that'd be square, like x squared. Now, it's probably like 10x squared or something to make it more narrow, but we just want the parent function. This one is the reciprocal or rational function. This one is probably this one over here, and it is, because it's 7 over x, so that means it starts at 1, 7 and comes down, and negative 1, negative 7 looks like that. So you can just graph that. Pretty self-explanatory. Same thing on this one, just use your calculator. But we know if it's the cube root, it's going to go up slow, like that. So up slow. Okay, now this one you got to figure out. So you first see that this says negative 3, and so that's the one that's less than 0. So then you go negative 3 squared, which is 9. So what I'm doing is I'm basing which condition, I'm sorry, these are the expressions and these are the conditions. I'm figuring out which one to use based on this number. So this is a 0, so it is 0. This one's a 4, which is greater than, so I've got to go 3 times 4 plus 3 is 15. Okay, on this one, f of 0 falls in this one, so 3 times 0 minus 2 is negative 2. F of 1 is also in that interval, so 3 times 1 minus 2 is 3 minus 2, which is 1. 5, okay, so 5 is the interesting one. This is less than or equal to, so I have to use that one also. 3 times 5 minus 2 is 13. But 6 would be in this one, so 6 to the third power minus 5, and you get 211. It's like 216, and then minus 5, because that's like 36 times 6. Okay, so that's number 16. Number 17, this one shows you your parts. Locate the domain. So because I know it's in two pieces, but it's defined for everything, so it's from negative infinity to infinity. The x-intercept would be based on this one, and that's 0, 0. Now, there might be another one, so let's graph it. So let's go to the graph. We were going to do this and go to this. 2 plus x, and this one's x squared. And this is x less than 0. And this one's x greater than or equal to. Okay, so we got the 0, 0, but also, if you see up here, that's 0, 2. Which is the y-int of 2 plus x. So how you can figure it out quickly is it's going to be this number. So that was a 2, so this is a 2. And the other one was based on x squared, and it went through 0, 0. Later on, you'll talk about types of continuities, and this is a jump discontinuity. And that was like this one A. I'm going to go ahead and label it jump discontinuity. Okay, the next part, the range, looks like it's everything. So it's negative infinity to infinity, because even when it's undefined right there, it is defined over there as you're going up. Is it continuous? No, it's discontinuous at x equals 0. Okay, number 18. The domain of this one, let's graph it. Well, based on the condition part, we already know it's negative 1 from this part. So this is your left. And since it's greater than or equal to 0, that means infinity is the right. So that looks like that. The x-intercept, 0 cubed is 0, and so that'd be your intercept. When you graph it, it would look like the C graph, and the range would be from 0 to infinity, because it's from the x-intercept up, and it is continuous. So 0, infinity for the range, and yes, it's continuous. Okay, just two more real quick. So this is about graphing on a piecewise. I need to pause this. Okay, so going back to this one, again, we just have two left. You have a piecewise function, and you notice it's not just a straight V graph like absolute value. It actually has different slopes. And so this one, you count down 3, and you go right 3. And so that meant that you have your slope is negative 1. And so your y-intercept for that one is 0. So this would just be the function negative x, and that's from negative 3 to 0. Now the other one you're rising 2, so this is up 2, and this is right 1. So that time you have a slope of 2, so this would be 2x, and that's when you put from 0 to 1, like that. Okay, and then the last one, you look at the left side, and this one you're rising, this is at -6. You're rising 3, running 3, so that meant your slope is 1, because that was rise 3 over run 3. And then you got to figure out, well, where was my y-intercept if it actually existed, and it would be at 6. And so based on that information, this would be x plus 6, and you have to fill in the 0 here for both of these. And then this one is simpler. It's just based on the parent function y equal x, because the numbers are the exact same. So you just put an x there. All right. The rest of them were just the answers to it if you want to double check. Hope that helps.